Okay, so this is the video that we kind of started in class talking about the equation of tangent lines. The target, of course, is students will find the instantaneous rate of change using the derivative process to determine the equation of a tangent line. So we kind of left off in class talking about the four parts. Remember, to find the equation of a line, you need two things. You need a point. Let me get a pin first, just like in class. We need an xy, and we need a slope. Okay, once we have any point and the slope on that line, we can write the equation of a tangent line. So there's really four basic steps. The first thing we're going to do is to figure out the y value. So find the y value. In here, we get slope by looking at the derivative. So that's what we're going to do, find the derivative second. And then we're going to actually find the slope by plugging in to our derivative, and then the equation. We always use point slope form. That's the most useful form for us for a lot of different reasons that you'll see throughout the year. But I do make one change. I like my equations solved out for y when I can. So that's the first thing I'm going to do is solve this out for y. So m times x minus x1. And then I'm going to add that y1 over. So I'll always go straight to that point. We never really have to simplify that unless we really need to. We can kind of just plug it in. We'll have the point, so of course is our x1 or y1, and then the m, we just plug in, and then we get the equation of the tangent line. So it's really just a four-step process. The y value, the derivative, the slope, and then of course the equation. So the first thing I'm going to do in my step to find the equation of a tangent line is to find my y value. Sometimes it's given, sometimes it's not. We find a y value by taking the given x value, so 4, and plugging it in. So the square root of 4 cubed minus, and I believe on your paper this was just an x, so we're going to leave it as that. So minus 4. If we simplify that down, the square root of 4 cubed, now a lot of people do not know what 4 cubed is. Actually, I believe this was 16 on your paper too. So scratch that. Let's kind of go back to this. I'm making mistakes all around. So we're really trying to find f of 16. I'm sorry about that. So we're going to take the square root of 16 cubed minus 16. Now most people don't know what 16 cubed is, but because a power and a root are the same thing, they're both exponents, we can actually do them in any order. So I'm going to actually take the square root of 16 first, which is 4, and then cube it second. If I do that, I get 64 minus 16, which is equal to 48. So the point I'm dealing with is 16, 48. So that's my point in my problem. The second thing is to find the derivative. So this goes back to what we've been doing for the last couple days. In my previous video, and you'll get some more practice tomorrow, the first thing we want to do is to put it in power form. So x, my power over my root, which is a square root. Remember, when there's no number on top of that small bar, it's a square root, minus x. Now that it's in power form, I can take the derivative. So f prime of x equals, and I can use the power rule here. When I subtract 1, I get a 1/2 minus 1. I want to simplify that out really quickly. So 3/2, that goes back to being a square root to the first power minus 1. So that's my second step, my derivative. This is the slope equation that's specific to the function f of x. My third step is to figure out what the slope is precisely at x is equal to 16, that point that we found earlier. So all I'm doing is plugging it in, and then to solve that. So that's 3/2 times 4 minus 1. 3/2 times 4 gives us 6 minus 1, which gives us 5. So this represents our slope. So between the point and the slope that we found within this process, we're now able to do step 4, which is to actually write the equation of the tangent line. And all we're going to do is plug in the m and the point into that formula up top. So y equals my slope, which was 5, x minus 16 plus 48. Now, if you want to simplify that, you can. However, that's the best form for calculus for a whole bunch of different reasons that we'll see down the line. But you can leave your answer like that. You don't have to simplify it. Let's look at another example. Okay. It says to find the equation of the tangent line of f of x equal to, and it gives us a rational equation at x equals 2. Now, I hope this is the right problem. If it isn't, rewrite your problem to match this problem. So just like before, the first thing I'm going to do is figure out my y value. So f of 2. Okay. I'm plugging in to that equation. So 2 raised to the 4th minus 3 times 2 cubed over 2. So 2 to the 4th gives us 16 minus 2 to the 3rd gives us 8. 8 times 3 gives us 24 over 2. That gives us negative 8 over 2, which gives us negative 4. So the point I'm dealing with is 2, negative 4. Okay. So that's my first step. Second step is the derivative. This is another equation where it's beneficial to rewrite, to simplify. So x to the 4th over x, that's one of those strategies. Even when we did sine and cosine today, this is kind of the strategy that we used. Not that. Let me go back there. Sorry, guys. I'm going to erase that. And that should be over x. Simplify that, I get x cubed minus 3x squared. A much easier derivative to take. So now I'm ready for the derivative process. So that's my step 3. Derivative f prime of x equals power rule, my constant multiple rule right there. Sorry, that is not my step 3, that is my step 2. I just keep making all these mistakes today. Sorry, guys. So my derivative, which is my step 2. So my 3, that's my plugging in. So we're plugging in 2. Remember, it always comes back to that point right there. So all we're doing is plugging in a 2 for the x. This represents my instantaneous rate of change for that curve at the point 2, negative 4. So we get 12 minus 12, which is equal to 0. So we got a slope that's equal to 0. If we think about our slope being equal to 0, that means our tangent line is in fact horizontal. But we can still write our equation exactly the same way. That doesn't impact. So y equals 0 times x minus 2 and a minus 4. If we wanted to get technical, we could rewrite this as y equals negative 4, because that's what it means to be a horizontal line. Okay. Next one, we're going to find the equation of the tangent line. Ooh, ignore that. Of f of x equal to 4 over x squared minus sine of x at x equals pi. So first step, plugging in. We're plugging in pi. So we get 4 over pi cubed, or squared, minus sine, let me fix that, minus sine of pi. Sine of pi, that is 0, so really we're left with 4 over pi squared, which I know is kind of weird, but the point is pi 4 over pi squared. That's okay. 4 over pi squared is a number 2. We don't judge. Okay, 2 is my derivative. I want to rewrite. Bring up that x squared. Okay, changing location changes sign. So I get that. F prime of x gives us negative x to the, or negative 8x to the negative 3. And the derivative sign we learned today was cosine. So there's our derivative. I want to rewrite that. To do that. My step 3 is plugging in. So f prime of pi. So I get negative 8 over pi cubed minus cosine of pi. So we have negative 8 over pi cubed minus, and the cosine of pi is in fact negative 1. So negative 1 minus a negative 1 will make that a positive 1. Now pretty ugly. So go ahead and write that down really quickly because I'm going to erase so that I can make some more room. Okay. If you need to pause it and erase. Hold on while I erase to make some more room. So we have some ugly equation, but it's okay. We have a point, we have a slope. Let's go with it. Okay. And sometimes they're ugly. So my step 4 is y equals my slope, which is at the bottom. Because it's multiple terms, I'm going to use some parentheses. And who made up this problem? Insane. So there's my m times x minus pi plus 4 over pi squared. That is super ugly, but it's okay. We don't judge. They're all numbers. Everything is where it needs to be, so we're done. Okay, so that's kind of the idea of finding the equation of a tangent line. Remember, we like the tangent line because it allows us to plug in values a little bit more easily. Maybe not this last one, but all the other ones made it pretty easy. Now, one of the big theorems is in fact the theorem that's here at the top. It says f is differentiable at c. That means, all that means is derivative exists. This exists. Okay. If it's differentiable, it has to be continuous. If there is slope, there has to be continuity. Okay. The contrapositive is also true. That's just the backwards in the not. It says if f is not continuous, then f is not differentiable. Well, obviously, we have to have a point to draw a tangent line to get a slope. You can't have slope where a point doesn't exist. Okay, so that leads to 3 different reasons a derivative would fail to exist. One is, of course, any type of discontinuity. Again, we have to have a point to have a slope. That includes a vertical asymptote, all 3 of them. A jump, and a removable discontinuity in RD. The second one is if we have a cusp. Okay. On a graph that is a sharp turn. We have to have a curve to have a derivative. So one example of that is in fact your absolute value function. And that is a terrible graph and I apologize. At that cusp point, that point right there, our derivative would fail to exist. It's not a curve. If we look directly to the left of that, directly to the right of that, we get conflicting slopes. One's going to be positive, one's going to be negative. That's terrible. We don't want that. So we don't have a curve, we don't have a derivative. And then 3 is a vertical. Anytime we have a vertical tangent line. Okay. And if we think about a graph like a circle, okay. If we have a tangent line at that point, let's say that point right there, we get a vertical tangent line. Well, we know vertical tangent lines, vertical lines in south, the M is undefined. Okay. Slope is not defined for a vertical line, therefore the derivative would not be defined there as well. Okay. Okay, I know that last example was pretty ugly. They're not all like that, and they very rarely come out like that. So go ahead and make sure you get your notes. Try the problems on page 49 in the back. Those are going to be a little bit easier. That way you can just get some practice both with the derivative and the equation of the tangent line. Come in and see me if you guys have any questions. I will be in my room in the morning, so I am on campus. Okay,